So today we'll be doing practice problems of functions. So now when you look at this graph, we have two graphs which are intersecting. And the first graph is the f of x, which is that function over there. And this is a parabolic function. As you can see, we have a parabolic function which is frowning. That's why we have a negative side in front of x over there. And also we have a linear function g. So we have a parabolic function and a linear function. So now when you look at the graph, you can see that these graphs are intersecting each other at A and C, and we also have other points on the graph which are A and B. So A and B, let's write that down. So A and B are x-intercepts of f of x. So we have x-intercept of f of x. And then we have A and E. So A and E, I'll say A, then let me do this. So A is also the x-intercept of g of x, and we also have E, which is the y-intercept of g of x. And the point C is the turning point of the graph of f of x. So getting to our first question, the question says we must find the coordinates of C, the turning points of the graph. So now how are we going to do that? So the first thing that we have to do is, let's say the first question, find the coordinates of C, the turning point. Now, how are we going to do that? So when we have to find the coordinates of a turning point of a parabolic function, what we have to do is use this equation. So we say at C, x is equal to negative b over 2a. So we use this equation every time we have to find the turning point of a parabolic function. Now, we are already being given the b value and the a value. So when we look at this equation of f, so we have a right there. So we have, let me write it down. So we have a x squared plus bx plus c. So when you look here, so we have a, which is negative 1, and b, which is negative 2. So we can plug that into our equation. So this is going to give us the x coordinate, by the way, and we'll have to find the y coordinate by using other methods. So we have a negative, and then what was our b value? It was a negative b, a negative 2, sorry. So we have a negative 2, and then we have a 2, and then we have a, which is negative 1. So both of this is going to be a negative 2 over negative 2, negative cancel out, and then we have a negative 1. So that is our x value. So we have x value for the turning point is -1. Now we have to find the y value. How are we going to find the y value? So to find the y value, we can always go back to this equation. Let me write it down again somewhere here. So the function is f of x is equal to negative x squared minus 2x plus 3. So remember, the f of x basically stands for y. So that is the y value. And we can substitute that x value that we got from the previous equation. We can plug it into this equation to find the y value. So what we have to do is just to plug that value in. So we have -1 squared minus 2 -1 plus 3. So the y value is going to give us -1 squared. That is just going to give us 1 multiplied by that negative. That's giving us -1 again. And then we have minus 2 and a -1. That gives us plus 2, then plus 3. So basically our y value is equal to 4. So now the coordinates of the turning point. So the turning point C is equal to -1, which is the x value, and then 4, which is the y value. So heading over to the next question, we have to find the coordinates of A and B. So when we go back to our graph, we said that A and B are the x-intercept of the graph of f. So what we know about x-intercept, so at the x-intercept, the y value of the graph is always 0. So let's rewrite the equation of the graph, so which is f of x is equal to negative x squared minus 2x plus 3. So the y value at the x-intercept is 0. So what we have to do now is to say at the x-intercept, y is equal to 0. And remember, I said that f of x just stands for y. So we have a y there, and that is equal to negative x squared minus 2x plus 3. So what we have to do now, just set that value to 0. So we have a 0 is equal to negative x squared minus 2x plus 3. So now we have to solve this equation. So what we have to do now, we can just multiply both sides by a -1 to get rid of that negative. So we can just do this, multiply by -1, multiply that by -1. So 0 multiply that by -1, we get 0 is equal to -1 multiplied by that negative. So we get x squared -1 multiplied by -2, that becomes positive 2x, and we have a -3 over there. So now we have to factorize this equation. So let's factorize. So we have 0 is equal to bracket, we have x, and we have x there. So now we have to find the values in which when we multiply them together they give us -3, and when we add them them together, they give us positive 2. Can you think of those values? So we have a 3, I'll pick 3, and we also have a 1. So when I multiply a negative 1 and a negative 3, I'll get a positive 3, but we don't have a positive there. So when I multiply negative 1 by positive 3, I'll get a 3 there, negative 3 there. So now when I add negative 1 plus 3, I basically have 3 minus 1, which gives me 2 over there. So now, so that 1 becomes a negative, and then that 3 becomes a positive. So what we do from here is we take this bracket and this bracket, we separate them together. We say x is equal to, let's say x minus 1 is equal to 0, or x plus 3 is equal to 0. So now we have to solve for x. So what we do now, we take everything to the other side, and we remain with x. So we have x, take that 1 to the other side, it becomes a positive 1. It's negative. When you take it to the other side, it becomes a positive. Same happens to this side. So we have x, and then we take a positive 3 to the other side, it changes the sign, and then it becomes a negative 3. So when we go back to our graph, so we have a 0 point there. So which one will be negative 3? The point A will be negative 3, because when we go to the left of the 0 side, we get negative numbers. So we have a negative 3 over there. And then when you go to the right of this value of 0, we get 2. Wait, nope, 1, sorry, we have a 1 over there. So at that line, at the x-axis line, so we have something like this, point A here and point B. So the value of y at the x-intercept is 0. So to find the value of A, we're going to say the value of A is x. X is negative 3, because we have a 0 there. So it's negative 3, and the value of y is 0. So we have 0. And the value of B is positive 1. And the value of y is also 0. So heading over to the next question, we have to find the coordinates of the y-intercept of the graph of f. So let's go back to the graph. So we have this graph of f right here. So we have the graph of f. Let me highlight it. So this is the graph of f. So we need to find the coordinates of the y-intercept. So this is the y-int of f of x. So let's go ahead and find the x coordinate. So remember, we have the graph of f of x, which is negative x squared minus 2x plus 3. So similar to the x-intercepts of f, the x value at y-intercept is always equal to 0. So we're gonna set all x values equal to 0, and then we're gonna find the y coordinate. So we already have the x coordinate, which is 0, and we have something like this: negative x squared minus 2x plus 3. So what we have to do, just plug that 0 in, and then we have, so that when you put 0 there, that goes to 0, that goes to 0. So the y coordinate is 3 and the x coordinate is 0. So what we have now is y int of f of x is equal to, the x coordinate is 0 and the y coordinate is 3. So let's look at the graph to confirm our answer. So when we look at the graph, the y values are positive above the 0. So that makes sense. We have our y-intercept as 3, that makes sense, is above 0. Now, next question, we have to find the length of CE. So we're looking for that length over there, CE, that length. So we just have to look at what we have. So we have this graph, we have its equation, we also have its intercept, we also have the turning point over there. And when you look at the graph of G, which is a linear function, it goes through the point A and point C, which are the points that we have. So now, to find the equation of G, we have to find the gradient first. So we have to find the gradient of this linear function. So how are we going to do that? So as I stated before, we have the coordinates of A and C, which are the coordinates of the graph of G. So we can use those coordinates to find the gradient. So we have to find the gradient first. So remember, the graph of G is like this. So we have g of x is equal to mx plus c, which m is the gradient and c is the y-intercept. So c is basically the y coordinate of E. So let's go ahead and find the gradient. So m, which is the gradient, is equal to y2 minus y1 divided by x2 minus x1. So remember, we are using the coordinates of A and B. So let me write it here, using A and B, no, and C coordinates. So the y value of C, remember we have C coordinate as -1 and 4, and we have the coordinates of A as -3 and 0. So we're gonna use those y values. So the second y, y2, which is 4, is up there. So we're gonna say 4 minus 0. And then we say over, we're using x now. So we have x2, which is x at C. So we have -1 minus -3. So this gives us something like this. So we have 4 over -1 plus 3. So that gives us 4 over 2, and that gives us 2. So which means our gradient for this equation is 2. So we have g of x is equal to 2x plus c. So now we have to find uh, the equation for this line. So we have to find the y-intercept of this graph. So now by using this equation that we have already, which has the gradient, we cannot use that method where you have to set x to 0 to find the y-intercept. So C is the y-intercept for this linear function. So we can't do this. Y is equal to 2x plus c. So we can say x is equal to 0 at the y-intercept. We can't do that because if we set x to 0, we have something like this now. So we have a 0 plus, so we just have c. And c is what we're looking for. So we just basically have an unknown value right there. So we can't use this method. But there's another method which we can use, is this method. So we have y minus y1 is equal to m, which is the gradient, x minus x1. So y is just another variable for the equation. So we have y1 is the value, the y coordinate at a. So the y coordinate at a is 0. So we have y minus 0 is equal to the gradient which we found previously. So we have 2x is just another value for the equation, and then x1 is the x value of point A, which is negative 3. So we have negative 3 over there. So now we have y is equal to, multiply that, so we can solve the bracket first. So we have x plus 3, and solving that we have 2x plus 6. So this is the equation for the linear function. So we already found the equation for this line over there, but we are not done. So because we have to find the length of CE. Now, how are we going to find the length of CE? So when we look at the graph, when we look at this, this line is a straight line, and we also have this coordinate right here, and we also have this coordinate as the y-intercept of the graph. So we have that value over there as 6. Let me just draw it right here. So we have something like this, and let's do this, something like this over there. Wait, is it? Nope. Let me draw that again. Or let me just copy and paste that. So we have the coordinates of C, and we also have the coordinates of B, so of E. So E is equal to the x value, which is 0, and the y value, which is that C over there, which is 6. So we have the coordinates of E and the coordinates of C, which is -1 and 4. So now that we have these coordinates, when you look at this in another way, when you look at this in another eye, so we have a right angle triangle. So we have a line there and a line there that intersect at a right angle. So we basically have something like this. where we have a right angle triangle over there. So we have E and we have C. So we know the value from 0 to E, from 0 to E, which is 6. So we have that coordinate over there, and we also have -1 and 4 over there. So to find this length, what can we do? So to find that length, we can say that value, the y value minus this value over there. So now this length is equal to 6 minus 4, which is equal to 2. So this length is equal to 2. And to find this length over here, what can we do? Is to say 0 minus -1. So this length over here is basically -1. So we have, let me do this. So we have 0 minus -1, which is basically 1. So this length is 1 and that length is 2. So now we can use Pythagoras theorem to solve for that length CE. So using Pythagoras theorem, so we can say length of CE is equal to the square root of x squared plus y squared, and this is equal to the square root, the x value, which is 1 squared, plus that y value, which is 2 squared. So this will give us square root of 5. So you can just put units over there. So next, we are required to find the equation of the inverse of g of x in the form of y. So remember, so this is the same as y is equal to 2x plus 6. So the first thing that we have to do to find the equation of the inverse of g of x is to interchange the values of x and y. So how are we going to do that? So we're just going to say x is equal to 2y plus 6. Now we have this equation. So basically what we did is we took that x and put it there. We took that x and put it there, and we took that y and put it there. So now we have this type of equations, but we have to solve for y again. So what we do now is that we can take that 6 to the other side. So now we have x minus 6, and we are left with 2y that side. But then we want y only. So what we do is divide both sides by 2, and that one also by 2. So now we have y, which is equal to -3 x over 2. So you can rewrite that as y is equal to x over 2 minus 3. So now that is the inverse of g of x.